Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new Redefining Security podcast. Have you ever thought that we are selling cybersecurity insincerely, buying it indiscriminately, and deploying it ineffectively? Perhaps we are. So let's look at how we can organize a successful InfoSec program that integrates people, process, technology, and culture to drive growth and protect business value. Knowledge is power, now more than ever.
Imperva is the cybersecurity leader whose mission is to protect data and all paths to it with a suite of integrated application and data security solutions. Learn more at imperva.com.
Pantera, the leader in automation security validation, allows organizations to continuously test the integrity of all cybersecurity layers by emulating real-world attacks at scale to pinpoint the exploitable vulnerabilities and prioritize remediation towards business impact. Learn more at pantera.io.
Everybody, you're very welcome to a new Redefining CyberSecurity podcast episode here on ITSP Magazine. And as you know, I help, or I try to help anyway, organizations understand the role of technology and people and processes in building out security programs in a way that fits operationally with the business. So enabling the business and protecting it as it grows, not getting too deep into the weeds and missing the real point of why we even bother in the first place. And this topic was presented to me, and given my background in quality assurance engineering, I was super excited to talk about this in the context of security testing. So we're going to be looking at the different methodologies for security testing applications and systems. And I'll just include the range of black to gray to white here, and we'll understand a little bit more what those mean. I don't know if there are other terms or shades that we can talk about as well. We'll figure that out. So thanks everybody for tuning into this. I'm thrilled to have Mario and Andrew on. They both have a different perspective to this particular topic and seeing it through to a program or project through to completion. And hopefully some tips and some stories to help us all kind of visualize a way to tackle this problem. So without further ado, a few words from each of you on who you are and what you do and why this is an important topic to you. Mario, we'll start with you.
Cool. Thank you very much. And very happy to be here. My name is Mario. I'm the founder and director of a team of penetration testers, a small penetration testing firm from Berlin in Germany. And we're called Q53. And we do pen tests, source code audits, and those kinds of things. And I'm usually the person whom you talk to for like everything contractual, quality assurance, report handover, and those kinds of things.
Love it. And Andrew.
Hi, it's great to be here. My name is Andrew Woodhouse. I'm the CIO of RealVNC. So we do remote access software.
And neither of you answered why it is an important topic. Why did you want to, well, first have do the program, the project, and then why is it important to you to share with others?
So I'll take from my perspective. So the audit that I think we're going to be talking about today is part of a wider security initiative that I put in place for RealVNC. And that comprised a number of things that I'm sure are going to be familiar to your listeners. One of them was software composition analysis. So we brought a tool in to look at our software, understand where we were using libraries that may be out of date, may be old, may have vulnerabilities in, and help the developers fix those issues. And also highlight any libraries that had, for example, license risks. So they might be GPL licensed, maybe that introduces risks into our commercial software that we have to be aware of. Another program was an ISO 27001 program, so aiming to be ISO 27001 certified, which is a very large project. And at some point, we can maybe talk about why we're doing that and why we think that's important. And another one was basically bringing Cure 53 in to audit our code, and not just from a marketing point of view to say, hey, look, we've done this, aren't we great? But actually help us improve our software and our software development process as well.
Both important parts, though. I mean, raising the posture, but also, I mean, it's smart to demonstrate and use it to help companies or customers make a good informed decision on which companies actually care, right? It's not just a checkbox of SOC 2, for example. Mario, anything to add there?
No, I would agree with those. And I would see what we do with penetration testing and source code auditing as just like one of many small components that can help to make a company or a product more secure. So it's not done yet. Once we're done, there's like lots of more stuff to do. But yeah, we're like part of that construct, part of that plan that helps you to make your software more secure, hopefully, I guess.
Absolutely. All right, so I'm gonna dig back into the recesses of my mind when I was a QA engineer, and I was responsible for many things in validating the quality of the software that I was building at the time. Big yellow company delivering tons of software products to the market, if you can picture that, who that is. And so the Blackbox testing that I did there was usually scenario driven, user story driven. We kind of understood the workflow and the business process and the business logic that the app was supposed to work by or work around or under, I should say. And we would test it externally, trying to get it to do that, to ensure that it did, and then try to get it to not do what it was supposed to do, to find those anomalies. And then I was also responsible for coding tests to test function calls and API calls and networking calls and data manipulation calls and validating data and things like that. And that was the Whitebox test, so black and white. Is it the same idea in security testing? Does that translate well? I don't know, Mario, can you maybe kind of share with us your view of Whitebox, Blackbox? Are there some shades in between there as well?
I think it's very close to what we would use as labels to describe penetration tests or similar security assessments. I'm not really sure if it's like exactly the same, but if you, for example, talk about a black box test and we talk about a test where we don't have much information compared to anyone out there on the internet. So we basically slip into a specific role, and after slipping into this role, the test becomes a black box test. And the role here would be like the uninformed attacker. Or we could do a white box test where we don't slip into the role of the uninformed attacker, but rather assume the role of someone who has all the insights, has access to the sources, to the configuration files, potentially SSH on the server, and so on and so on. So we become more of an auditor, still with a main interest of doing bad stuff or finding the spots where bad stuff can be done, but simply with a different pair of goggles on and with a different level of visibility and insight that we have. So we can get more stuff done, but we might also miss things that are only visible from the outside. So it depends a little bit on what you want to achieve and how you want to achieve it.
And Andrew, the role of both of those in your program.
So
describe that to us.
Yeah, so we do both, and both are important in different ways. So we commission black box pen tests, and that's really, from my point of view, and you know, we might disagree about that, but from my point of view, it's a much more common thing. It's a much more well-known thing. You know, there are many organizations that can do it, and very often a lot of the things they're doing, you know, they're running as a lot of standardized tools, and it tends to be, without sounding controversial, there's, you know, it's a lower skilled exercise because there's a lot of tooling out there. For example, for web applications, a lot of the issues and the things you're testing for are already known, and things like cross-site scripting, et cetera, that are well-known issues that have been solved. So you're looking for coding errors, configuration errors, but and we do Blackbox tests for our basically our web apps. But due to the nature of what we do, there's also client software, and we don't do Blackbox tests of that. So the reason we wanted to do a Whitebox test is I felt, and I might have been wrong, that in order for the test to be really valid, to help us improve our software and to be beneficial to us, not just a rubber stamp on a piece of paper that a customer can see, I really wanted an external organization that had people familiar with, the tech stack we were using, to actually go through my view was we need to go through our code with a fine-tooth comb, because with the best will in the world, doesn't matter how good your developers are, there will be things that they miss, right? So sometimes another pair of eyes, another perspective on looking at the code is useful. So that's a very long way of saying we do both, and I think they're both quite different.
Yeah, absolutely. And I think, we could probably spend the entire conversation debating on, and probably not even debating, just discussing where the value of one is and where it stops and the other one picks up and where it overlaps. But let's stay focused on the Whitebox. So some information. You mentioned tech stack, Andrew, and I want to maybe start here in terms of scoping, right? So with as much detail as you are comfortable sharing, what does a tech stack look like? Where I presume it uses some cloud. Do you have some shared responsibility agreement with the cloud provider? So maybe kind of walk through the stack of an application, let's say, maybe not everything you're looking at, but something you want to share.
Yeah, sure. I guess the first thing to say is if there's a technology out there, we're probably using it somewhere in our tech stack. And I think Mario probably did a bit of a gulp when he saw when he got a list of the technologies we were using. But I think, like most complex applications, it's very hard to limit the tech stack, because then you have to develop. The reality is you have to develop in the tech stack that A meets the solution and B can be done in a timely fashion with the resources you have. So ultimately the core of our application is C++, right? There are clients, there are servers and things like that are installed onto client endpoints. So that automatically added a level of complexity to an audit, because we needed a team who could not just do more mainstream technologies, maybe like JavaScript and Python and things like that, but actually in our case C++ and Go were two of the big ones that we really needed to engage in as a specialist organization that could cover those.
And quickly before you jump in, Mario, what the C++, clearly not a fresh off the shelf language here, right? So the decision there to use that, legacy applications, you're continuing to build on things, or just the power and capabilities at the endpoint that you needed with that language?
I think it's a combination of all of them. I think, the company I work for has been in business for 20 years and it's evolved over 20 years. And there's never been a compelling reason to move away from C++, to be honest. There's nothing wrong with C++. It's one of the things that, we really need performance, and we really need C++ is, if we had an interpreted language, it arguably might not be as fast. Performance is important to us, as is the size of the client, the client software. And we have to use Microsoft Teams every day in work for doing business. And if you look at Electron apps, they might be really nice and easy and cross-platform, but they're massive and probably riddled with a whole lot of security issues that are outside of the code that you're writing. So with C++, we're a bit of an extreme example in that we've written everything from scratch. Because 20 years ago, a lot of the tools weren't there, a lot of the libraries weren't there. So, and that's why the Whitebox audit, I think, was quite a big exercise, because, we have a protocol. We're not just an off-the-shelf solution, a kind of pick up the bits and bolt them together. It is a solution that's been developed from scratch with a protocol and things like that. So while C++ is possibly legacy, and if we were doing it now, we might use something else, there is no compelling reason to move away from it. And we've got 20 years of learning how to write C++, to be honest, as an organization.
Yeah, a lot of tribal knowledge. Mario, what? So tell me about the gulp moment.
Well, that was me saying that. Mary may disagree.
I know.
I think there wasn't that big of a gulp moment, but what could be interpreted as one is when you learn about like how many lines of code are there. Because like if you talk about scoping of a pen test or an audit, you initially need to know what's there. So you ask like two questions. The first question that you ask is what's there from a high level perspective, and then you get answers like 2 mobile apps and 1 client and 1 web application and 1 API, something like this, just like really roughly described. And then the second question is like, okay, so for each of those, what's there in terms of code? What's it written? What kind of frameworks? How many lines of code? How many API endpoints? How many user roles? Basically everything that gives you some insights about the metrics of the scope objects. And when we learned about the number of lines of code in this particular example, we were like, oh, that's a lot. Well, that was also expected because it's a lot of software and there's a lot of scope items that have been placed into scope. So needless to say, we were, I'm not sure if I can talk about this, but somewhere in the 7-digit numbers, if I remember correctly, with the lines of code. And that is, of course, a lot.
But just to pick up on that, I specifically didn't want just one part of our solution tested. From my perspective was there could be vulnerabilities anywhere. We hear all the time about, people, attackers pivoting from one vulnerability to another vulnerability. So I regarded for the Whitebox audit, pen test, whatever we want to call it, it really needed to involve our entire stack, and that includes all the mobiles app, the cross-platform applications, the web app, the back end, because if we hadn't done that, I would be worried that we didn't have a 360 view of everything that was going on, and it would kind of hobble Mario's ability to do his job by excluding certain things. And if I were I'm a bit paranoid, and I'd be thinking, if I were Mario, I'd be thinking, what are they hiding here?
Yeah, and maybe Mario, as you if you don't mind drilling deeper into this, I mean, yes, there are elements or components, right? You have a web app, desktop app, mobile app, backend service, data stores, networking, cloud service, I don't know, whatever all the things are. They individually work a certain way, but connected, they also allow the system to work a certain way, perhaps differently than they might on their own. And so, Mario, how did you go about breaking down and analyzing the subcomponents of the subcomponents to understand? Because I mean, a mobile app might work differently than a desktop app, right? And may call different APIs, may call them differently, may pass different parameters, may blah 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 blah. How do you get to that point where you're looking at the right elements in the right way?
That is actually not that complicated in most situations, because the different kinds of products that a company is offering that are supposed to be looked at already give you like an orientation how your work package should look like. And then the technical details about each of the components tells you exactly who from your team should be looking at the whole thing. And then what you need to do internally is to find out which ones of those components are actually security critical and which ones are not that security critical. I would go as far and say that the core libraries that a software might be using, or the API that a software might be exposing, is critical because all the good stuff happens there. And I might also argue that potentially the web application, if it's just consisting of like a UI or something that is like a single page web application running in your browser, is important, but not that super important, because you can't get direct access to the data. You can maybe find a cross-site scripting or something like this, but then you remain most of the time in the client. And then last but not least, you look at the mobile apps and like, okay, so they're installed on someone's device. Those are important. They have their own threat model, but they're in no way as important in most situations as, for example, API core libs or pretty much everything that is there written in C++, because entirely different threat model, entirely different risk that is behind it. And then you already kind of start seeing a map shaping up and knowing like this is one component that talks to the other component. So those people assigned to this component need to talk to the other people assigned to that component. And then at some point becomes reality and it gets specific and something concrete falls out. And then you have a plan. Usually it depends on the technology. It depends a little bit on the customer. It depends a little bit on the domain-specific parts. But at the end of the day, you usually find answers to those questions quite quickly. And you know exactly, okay, this is one element. This is one compound of things. Let's audit this with this level of prio and the other ones with another level of prio and so on.
So yeah, you want to add something there, Andrew?
I was just going to say, in our case, the bit that I think we were all most interested in was the security of the protocol that we use that underpins our application. And actually most of that code is shared between the desktops apps and the mobile apps. So I think that made it achievable because it's a different front end kind of wrapper around fundamentally the same protocol. And a lot of the libraries are shared.
Yeah, because I'm going to go out on a limb here and assess that Andrew has kind of a good view of what the environment looks like. And Mari, I don't know if that's typically the case, where somebody can say, this is what my infrastructure looks like. This is what the ecosystem components looks like. Tell me where I need to invest some additional controls or policies or whatever it might be, versus a company that says, and because Andrew's been building this stuff for 20 years, right? Or at least a company has, versus a new startup that basically builds apps using 90% shared libraries, a lot of them open source, and then they write 10% of the code themselves, and have very little view, perhaps, of what's what. So any thoughts on that dichotomy? Does it change things much?
I mean, the word that we're after is probably inventory. So if you're working for a company, you need to know your inventory if you're in the respective role. If you do not know your inventory, then you cannot really determine what needs to be tested. You cannot really determine where the risks are, where threat actors might actually become active. So this is like one of the key bits. You need to know what you have, and you need to know what you're sitting on to be able to make like a conscious decision about what should be looked at in the next audit, test, vulnerability assessment, or whatever you're going to be running, even if it's just bug bounty or something like this. You need to know what is where and what is the risk, and can people even look at it without breaking stuff? Because it could also be that you have something in your stack that once it is being pen tested and receives more requests than usual, that it just collapses, and then something critical might collapse. We've had that in the past. It can happen. But I doubt that it's possible to do security productively without having a clear idea about your inventory.
I think, Sean, you picked up on one of my little bugbears, and some of your listeners might fundamentally disagree with this, but a lot of the time, particularly startups, we've all seen the developers who copy and paste code from Stack Overflow, or they use stuff from cloud providers that maybe they don't fully understand. And as soon as you start doing that, then you raise the risk, right? Because you don't know what you're dealing with. You don't necessarily know how the code's working. And if we think about things like some of the horror stories around NPM recently, where developers are just pulling packages and they don't necessarily know what they're doing, how they're working, there could be vulnerabilities in them. So I think I'm in a nice position in that because we've been around for a while and we've written everything ourselves and we're not a startup, I think we're in a luxurious position of probably understanding more about our code base than a startup that is under massive. And I think dev teams, I'm not a developer, I'm an IT guy, but dev teams are under massive pressure to ship quickly. And we all know that corners get cut, and that sometimes security is not necessarily front and center, because there's this drive to ship from investors, from the market, wherever it's coming from. And I personally think that it's the rise in the number of data breaches, the number of security vulnerabilities. I think there is a correlation with the number of, startups that are working, writing stuff really fast, getting it out there. They might be doing some really cool stuff, but is it secure? I don't think even they would claim it was.
I do agree. I mean, that's a luxury position to be one of the first who actually offers a specific kind of software, a specific kind of service, because you have more time than others. If now someone came and said, like, well, we're also going to get a foot in the door with like remote desktop remote connection services, how are we going to be able to catch up as quickly as possible with real VNC? Well, we use as many of the things that are already out there as possible and glue them together and hope that it flies. And then the consequences, of course, that you're definitely going to have some level of bugs. You're going to have some level of security problems because you do not know exactly how each of the components that you glue together works and what the pitfalls are. And then one of the components might have an enhanced set of features that you never heard of, or you didn't read the docs properly. And then it turns out that it can do things that you never anticipated, and the whole thing falls apart because something that's user controlled goes into an eval or something like this. We've seen that not in the remote connection business, needless to say, but in other businesses where this tends to happen. There's some first mover, then another company wants to kind of catch up, and then more want to catch up because it's good money, and then software comes out that, yeah, it works, but that's pretty much all. So,
yeah, I was going to say quickly, Andrew, and I want to hear what you say, but just we can't forget that security is at least a three-legged triad, right? Confidentiality, integrity, and availability. We always focus on confidentiality and has it been compromised where a service can be used to do something else, where availability is key as well as integrity, right? We want to know that the apps and its data has integrity too. Sorry, Andrew, go ahead.
Yeah, I was just going to say, and I think this problem is actually, if you think about things like OpenSSL that pretty much every software uses out there, there are, I don't know how many lines of code there are in OpenSSL, but there are regularly things that come up that some really old feature that nobody uses anymore is still in the code and suddenly gets exploited. So understanding that inventory is super important, and just be aware, I guess, if you're writing software and you have TLS libraries that are fundamental to your solution. It's very easy as a developer to start using one. It's not necessarily easy to make it work securely. Even though it's TLS, it doesn't necessarily mean it's secure.
So Mario, where does the Whitebox, the understanding of what's inside really come into play here? I've heard Andrew speak to the protocol. I presume it's a standard protocol that the app's been built around. I just mentioned SSL, OpenSSL, standard way to securely communicate, right? So those are perhaps two inside elements that external people might know enough about to then compromise from the outside or from the inside if they gain access inside somehow. So where does the Whitebox stuff come in, where it really drives better value, I guess, in the assessment, the audit, than a Blackbox test would?
I think the key word here is complexities. So if you take a piece of software and that software is just like pretty much like any other software of the same kind out there, like a simple web application with a bunch of forms, then you might do a white box pen test, or you might do a gray box pen test, or a black box pen test. But in the end, the results are not going to differ that much because that thing is simple. That means even without lots of insight, you can get a good grasp of it, and you can understand it, and you can make the right decisions and make the right estimations as a tester, and eventually reach something that you could label as completeness in terms of coverage. Of course, you're never going to be fully done with your coverage, but you can get close. But as soon as you have a certain level of complexity, you have to make too many assumptions about what is there, what might be there, how it works internally, what kind of layers are there. So at some point, Whitebox or Crystalbox is the only way to actually go, because you need that insight and you need to kind of have that visibility over certain complexities on the stack, because otherwise all you can do is guess. But the amounts of guesses that you have to do, and I mean, to be quite frank, black box testing is usually guessing. The amounts of guesses that you need to do with the raising level of complexity grows exponentially. So at some point, you just like can't guess enough anymore to reach a level of coverage that is sufficient.
I think a good, just a kind of practical example springs to mind. With our software, for example, we delegate authentication to the operating system. An outside attacker is not going to see how that works, how those system calls are done. Are they handled properly? Are failures handled properly? Things like that. That I think only from seeing the code are you actually going to know how that process is working.
So,
Exactly. No.
So that leads me to two things, and this may be what we talk about for the rest of this. The first part is you do the audit, you get a ton of stuff back. How do you absorb that? You hear umpteen stories of we got this pen test, nice PDF, gets put on the shelf, and we never look at it again. So how do you ingest what you find? But then also, perhaps, how do you use that in your learning to build the next iteration, not just fixing the bugs that perhaps were found or vulnerabilities that were found, but perhaps designing in the way you just described, leveraging the OS, right, which does have some separation there, which makes it more difficult to understand, therefore difficult to compromise. How do you do those two things, Andrew?
So the way we worked with Cure 53, which is probably normal for Cure 53, but it worked very well for us, is effectively Mario's mentioned work streams. So the audit was divided into 4 pieces of work that mapped onto our 4 development teams. So we had the right people available, and effectively as they were finding things, we were using a system like Teams or Slack or whatever an organization uses, but Cure 53 had the ability to ask questions to our developers. Hey, why have you done things this way? Can you clarify what this is doing? And then anything that was found which was concerning to Cure 53, basically we use Jira like most organizations. So Jiras were created to fix those things, and I don't think it wouldn't be realistic for any audit of the size of what Cure 53 did for us to find nothing. They did find some things, thankfully no criticals. But effectively, as Cure 53 were finding things, the dev teams were raising Jiras, and actually the second phase was Cure 53 reviewing the PRs, reviewing the pull requests, and confirming with our dev team that from their point of view does fix it. And that process worked really well. And actually, we there were some 30 odd issues that were fixed in this process, and all of them were kind of validated by Cure 53. So the external party that found the issues then validated the fixes, and that worked really well for us. So they certainly weren't left on the shelf and withered. And as I said, we didn't do it as a rubber stamping exercise for customers to say, hey, look, we've done this thing, aren't we great? It was we genuinely had the desire to make our product better and more secure.
Which is also probably something that we can use in the discussion around Blackbox versus Whitebox, because with Whitebox engagements, you usually have like way more communication with the client. You have like the possibility to verify fixes based on diffs and PRs. You have communication during the test. You can ask anything. They can ask you anything, because you're not the external attacker. You're like someone sitting with them, next to them, etc., etc. And that also kind of gives you more depth, especially when the complexity levels are high.
So, yeah, before we go to the next round of development cycle, how did this fit into the broader picture of your security program, Andrew? And how did you communicate what you did, how it was completed, the results of that to those that matter? And who are those that matter?
Well, I guess ultimately those who matter are A, our investors, and B, our customers. So how did we communicate it? Internally, we circulated the Cure 53 full report to everyone. And I was particularly interested in improvements that Cure 53 could identify in our software development process. So some of what Cure 53's report contained was some recommendations on how you might want to consider doing X, Y, Z. And then that was taken by our engineering team, by our CTO, and action. So a good example, for example, Cure 53 said, hey, you might want to consider doing fuzzing, and here's why. And that went into our kind of dev pipeline. And then for customers, you know, I really believe in transparency around security, because ultimately anything less than transparency is a little bit smoke and mirrors. We couldn't publish the full Cure 53 report simply because it contained quite a lot of proprietary code extracts that we didn't necessarily want out in the public. But we published a summary report that was a warts and all report. You know, it wasn't perfect, and we weren't looking for it to be perfect. We wanted to give customers a level of confidence that there are no skeletons in the closet, and also to help us, as I said, improve our software.
And Mario, from your perspective, stepping out a bit, I think my perspective is pen tests are always give me all the negative stuff that I need to go address. Do you find generally and or specifically with Andrew's program some insights into where their development process has been working well for them, where you didn't find things you would normally find at other organizations, that you were able to communicate back to Andrew to say, keep doing this because that is helping you reduce exposure and reduce risk?
That's a bit hard to answer without sharing any internal details. But it's not unheard of that after a penetration test in general, you can say a lot of negative things, and we need to say those things, like, because if we don't, then someone else will, and they don't write a report at least. But there's oftentimes also good things that you can report. You can, for example, report good things such as fantastic communication during the penetration test. And you can also report good things such as every question that the team asked was like answered within minutes or like half an hour or an hour. You can, for example, also make a good attestation about the people in the right roles having the right insights and really knowing what they do. And you can also, for example, positively attest that there's like a fantastic security climate or fantastic security culture, or that certain things that you usually find in different but comparable platforms are just simply not present in this particular example. If we, let's say, run into a situation where we look at a complex website and we just like don't find any cross-site scripting, then this is weird, because we always find cross-site scripting, at least in most of the cases. And then we say something about this, because then it's clear that this topic is really under control. And we can say, well, if you folks are going to plan for a training or something like this, skip the XSS model because you got this under control. It's actually looking good. I mean, we don't know, of course, whether this is really the case, because we cannot see the entire company, only like snippets of it or like parts of the products that we look at. But still, you know where I'm coming from. It is oftentimes visible that certain vulnerability patterns or certain bug classes don't exist. And then you can say a nice word about this actually working. Whatever concept is there, it's working well, and you don't have this particular problem. And I believe that there was a bunch of issues that we actually flagged as very positive with Real FNC as well. And in the final conclusion of the internal report also positively noted as well, this is fantastic. There wasn't any crits. This is a good thing. There was a bunch of high, but not too many.
Well, given the size of the code base, that's probably quite unusual.
Yeah. It's pretty impressive indeed. We have found similar examples with similar networking and desktop software running with like 6, 7, 10, 12 crits. And that's a disaster. And that was not the case here. So that is also something that warrants for a positive remark.
So Andrew, talk to me about the culture there. Because that doesn't happen accidentally, right?
Yeah,
this is something that you've done.
So at the risk of, I don't know if you know the background of the company, but the company was founded back in 2002 by the original developers of VNC, who worked in the AT&T research lab in Cambridge. So they were academics, they were computer scientists. AT&T decided to close that research lab, and there were some organizations that I probably can name because I think it's pretty public. There were some organizations like Intel who said to the founders, "Hey, we really see a future in this technology. We kind of don't want this technology to die." So they effectively gave some seed money to start this company to continue development of this thing that they've developed under the AT&T umbrella. Originally, it was open sourced, and effectively since 2002, the company has been continuing developing the commercial versions of this thing that was originally open source. So I think in terms of culture, it's a very kind of engineering led culture from the very earliest days. And I think, I think security is, everybody knows, and it's not marketing speak to say that as an organization, we know we live or die by the security of our product, because in remote access, if customers get compromised and we're culpable, it's existential for us, right? If our product has fundamental weaknesses. So we all, from the CEO down, security is absolutely something that we will not compromise on. If we are on, like all commercial organizations, we're under pressure to release more, to do more numbers, to do, sell more software, etc. But there are some red lines, and compromising on security is absolutely one of those red lines, and we all understand that, and that's very much central to the culture. And we see it as we like to think that we invest in our product by investing in the security of it. So in a lot of organizations, security is seen as a drag factor. It's something you have to do with a kind of sad look on your face. We've written this amazing web app, now we need to make sure it's secure. But for us, security is absolutely essential, and it's at the core of what we do, actually.
I love that. And it's the exception to the rule, I think, where people understand the importance, and then people believe, probably even less, that believe and are passionate about proving or demonstrating that it is important. And then there's a reality of doing it. And I want to close with this, and I'll give you a final word as well, Mara, before we wrap. But Andrew, maybe one more slice on the culture, because this is an important piece. You've built a team that not only believes but actually does it. So are there ways you run your meetings? Are there tools you use? Are there rewards, or how do you kind of keep it going beyond just we believe in security?
That's a really good question and a really hard question, I guess. So in our SDLC, so we try to follow the Microsoft SDLC. So, we're trying to do that whole shift left thing of bringing in security very, very early in the earliest conceptions of new features and functionality. So there's that side of it. So the developers, and they never get a chance to write stuff that's insecure, because we have security people saying, "Hey, where's your threat modeling? You haven't done that as part of like non-functional requirements, for example, for a new feature." That's the kind of the stick approach of, "Hey, we're not, what's that? You can't release that. Have you thought about X, Y, Z?" From our security team, who we have the guy that kind of heads up that function, as actually interestingly picking up on something you said earlier about QA. He joined us as a software tester, and he found he was interested in security, so then navigated and was more interested in specifically security stuff. But he has the background of like QA testing, of automated testing, of what good tests look like, what challenges developers and testers are under, so he can talk their language. And I think one of the where a lot of organizations fail is where security is imposed by, where it's not a conversation, where it's just imposed. And I think the fact that, yes, it helps that we're a fairly small company, but where devs and security, it's a mutually collaborative thing rather than just a brick wall that you can't talk to. And I think that's super important. And I think that's a big part of, I think that's really important, that security can be a conversation, and rather than like cybersecurity coming in with a big hammer and hitting someone over the head, they can talk to the devs and explain to them and bring them up to speed with why maybe that isn't their best approach. And that seems to work well for us. I think in larger, I used to work in big companies, and security was a very removed function from development. And it tended to, and I think this is where the whole shift left thing comes from, security tended to be the final check before stuff released. And that clearly causes antagonism, because the developers have spent a lot of time and a lot of blood, sweat and tears developing something only for it to be kicked back at them because there are security issues with it. And I think the more you can bring the security teams and the security experts integrate that into the development process, I think that's hugely beneficial.
Yeah, I love it. And Mario, we're speaking to those security teams here. So any advice for them on how best to approach a Whitebox security test? And I presume it's going to be driven by communications to start, but what else could you say to help them really prepare for a program that succeeds?
I think most of the good ideas and thoughts about this that actually work in practice were already mentioned by Andrew. Communication is key. And you can never have a situation where the security people become sheriffs and just like randomly make decisions, but do not shed any form of transparency to developers or other people why those decisions were made. So there needs to be an understanding. There needs to be an understanding from the end of the security team to the development team to understand what their needs are and what their concerns are, and the other way around as well. And that is eventually what you need for good culture. We can always, as pen testers, always at least try to kind of chime in and not work against that. And that is why we, for example, try to be as close as possible to the customer during a test. Always recommend to do at least bright gray box, if not white box, because we don't want to be those sheriffs. We don't want to be like the external cavalry that comes riding in, shoots everything into bits and pieces, and then leaves again and doesn't leave you anything in behind that you can actually work to kind of repair your stuff. That doesn't make any sense. You can do this. You can follow this approach, but it doesn't really help. And what I noticed over the past years as a pretty good indicator to detect whether you have a good security culture in your in your company already, or whether there's still like room for improvement, is not to look at the tests and the test results and all those things, not to look at the crits and at the bugs that you found, but to look at the fixes. Because from the fixes, you can read so much. You can read from the fixes via the timeliness as to how focused the team is on working on those. You can also read from the fixes how good they are, how spot on they are, if they actually address the issue, or if they fix an entirely different problem, or fix the problem just like halfway. And you can always also learn how those fixes are being created, how they're being presented. In some situations, the client comes at us and said, like, well, all the fixes are in, the application is now fixed, have another look. It's like, we can do that, but it's not great. It gives us the possibility to tell you in a blurry and vague way, we guess it's all good, but we don't really know. So, yep, that wasn't really worth anything. Or they could say, look, here is a zip file, and in that zip file, you have diffs, and the diff file name is actually numbered after the ID of the bug, so you know exactly what issue that diff is addressing, and there's only that code in there that is necessary for the bug to be fixed. So happy review time, you're going to be done in half an hour. And we're like, oh, wow, that is fantastic. That is exactly how it should be. So as I said, I do not really know what and how many things you need to do to kind of build up a good security culture. I know a couple, but not all of them. But I do know how to actually measure this, and that is pretty much by looking at the fixes and understanding how well they became and how fast they came in, how accurate they are, how they're presented. And then last but not least, also looking at the fixed application after all and checking, did all the same bugs come back, or did they actually have a learning effect and eliminated that particular bug pattern? You will never find XSS in this application because they understood it in full, communicated it well, and now it's gone.
Super cool. That's brilliant, Mara. I really appreciate that. I presume a lot of our listeners can resonate with that as well. It's always difficult measuring success in this world of security. So thanks for sharing that. And Andrew, thanks for sharing your program with us, giving us some insights into why and how and the results that you have. And I think for me, the big takeaway is you not only care, you believe, and you respond with that belief as well. It seems based on this conversation.
I think security is an investment.
Yeah.
And I think very often it's seen as a cost, but we need to change it around to it being an investment. In the same way as IT often seen as a blocker, security is often seen as a blocker, and there are possibly good reasons why they're doing things, but it's about how you communicate why you're doing this stuff, so that you're not seen, as Mario said, as the sheriff coming in, shooting everything, and then riding off into the sunset.
That's right. Bang, bang, bang. Nice one. Well, thank you both again. Appreciate the conversation, and thanks everybody for listening to this episode. We'll include notes, of course, for you to connect with Mario and Andrew. And I believe there was a blog post that kind of highlights some of this stuff, which was the catalyst for this conversation. So we'll share that as well in the notes. And stay tuned for more conversations here as we continue to redefine cybersecurity. Thanks, everybody.
Thank you very much.
Thanks.
Pantera, the leader in automation security validation, allows organizations to continuously test the integrity of all cybersecurity layers by emulating real-world attacks at scale to pinpoint the exploitable vulnerabilities and prioritize remediation towards business impact. Learn more at pantera.io.
Imperva is the cybersecurity leader whose mission is to protect data and all paths to it with a suite of integrated application and data security solutions. Learn more at imperva.com.
We hope you enjoyed this episode of Redefining Security podcast. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.